certainly do. Oh. But Pebble. I sure hope you're not like this tomorrow. I really... Pebble. So, I recommend those that are interested is this paper. News reports are starting to emerge that thermobaric weapons are being used in Ukraine. And the purpose of this video is to educate on the medical side what the effects of
Spoiler alert, you gonna die.
Is not only to illustrate the absolute horrendous effects on human beings, but also to help healthcare professionals in the theater of war deal with the aftermath of these weapons.
Vacuum bomb.
This is a TOS-1 Russian tank that is able to launch up to 6 kilometers, 24 different missiles. Each one of these has the capability of being a thermobaric weapon, and we're going to discuss exactly what that is right now. The anatomy of a thermobaric weapon here, you've got the shell, of course, which is in yellow, and it's filled with either liquid or fuel. Sometimes it's ethylene oxide. It's basically a combustible fuel that it is filled with. And in the center of this is the detonating charge.
See this? This is my boomstick!
The next thing that you have to understand is that there are actually two detonating charges. The first detonating charge causes the missile to explode in a way that it distributes this liquid as a cloud throughout the atmosphere in the vicinity of the initial detonating charge. This would appear as a cloud of dust or a cloud of mist, which is fuel. With the air around the bomb saturated with this fuel mixture, there is another detonating charge that ignites this fuel and causes it to instantaneously combust, sucking the oxygen because combustion requires oxygen for the reaction to occur. It sucks all of the oxygen out of the atmosphere. Now, as a result of this, the pressure that is generated from this bomb in this area is on the order of 427 pounds per square inch. Just to give you an idea of how much that is, we inflate our car tires usually to around 30 psi. And the temperature of this blast is around 5,000 degrees Fahrenheit. And just to give you an idea, the surface of the sun is about 10,000 degrees Fahrenheit. And the velocity with which this pressure wave travels is about 6,700 miles per hour. This weapon is so powerful that some experts consider this to be at the same level as a low-level nuclear weapon.
Now we're going to check out these waves, just because I'm feeling very sciencey today. Today's Mars. It is day 2 in the red magnetic moon. Is it moon? Yeah, it's moon. Red magnetic moon wave spill, which is the very final wave spill of the Green Castle of Enchantment. Yeah, I don't even know what that means, but I know that it is. I know that I'm a white magnetic wizard. I know myself. I have no idea where I am.
The wave transmits energy and can encode information. Yet each individual atom stays pretty much in the same spot. When a wave reaches the end of the rope, the wave and its energy are reflected back. If the end of the rope is fixed and can't move, the reflected wave is flipped upside down. If two waves collide, they pass right through each other. When the two waves are on top of each other, they can momentarily cancel each other out. When the two waves are on top of each other, they can also momentarily strengthen one another. Here, the two waves strengthen each other where they intersect. Now suppose we have more than two waves. Now suppose we have an infinite number of waves. This wave is composed of an infinite number of waves that spread out in all directions. When added together, they form a wave that travels in just one direction. Let's consider what happens when this wave hits a barrier with a small hole. The waves behind the barrier are blocked. Only the wave behind the hole passes through. Since this wave no longer has the other waves to combine with, there is now nothing stopping it from spreading out in all directions. This is the reason why waves spread out when they pass through a small hole. Now suppose the hole is bigger. If the hole is bigger, then more of the waves are able to pass through. If the hole is small, the wave spreads out in all directions. If If the hole is bigger, most of the wave keeps moving forward without spreading out. To understand why this happens, consider the pattern that forms when a wave passes through a large hole. The waves going to the sides often cancel each other out, whereas the portion of the waves going forward always strengthen each other. However, if the distance between the incoming wave peaks is much larger than the length of the hole, then the waves that pass through the hole strengthen each other in all directions. The wave spreads out when the distance between the wave peaks is much larger than the length of the hole. If the distance between the wave peaks is much smaller than the length of the hole, then the wave moves forward without spreading out.